Today, I will be going step by step on how to program an ATtiny45 or 85 using an Arduino as the programmer without getting any errors. Because while there is quite a few guides on how to do this, quite a few of them leave out some key pieces of information which make it very difficult for a beginner to actually do this successfully. I remember when I first learned about the ATtiny about 10 years ago from a video by Make Magazine, it took me quite a long time to be able to actually program one of these using the Arduino. I was very new to electronics at the time, and I remember being quite confused the way the tutorials would go between the digital pin numbers and the physical pin numbers of the chip, without really making it clear which one they're referring to. And even when I managed to get the wiring correct, I always ran into errors when trying to upload using the Arduino as programmer. And I would become frustrated every time because it would work for the person in the video, but whenever I tried it, it would always give errors in the IDE. So I'm hoping to make this video the tutorial that I wish I had when I was learning about the ATtiny and how to program it with the Arduino, so that even someone brand new to electronics can get one of these up and running. So I'll start by briefly explaining what makes the ATtiny so special. So to put it simply, an ATtiny is a baby Arduino. So just like its bigger brother, the ATmega, which is present on the Arduino boards, the ATtiny is an AVR-based microcontroller capable of running Arduino code uploaded from the Arduino IDE without the need for any external supporting electronics like an oscillator or capacitors like with the ATmega. Now, of course, it is limited in its functionality compared to the ATmega, as well as only being able to support a fraction of the libraries that you can run with the ATmega. So here I have some ATtinys that I've been collecting over the years, and the one that I'm holding right now is an ATtiny45. It features 8 kilobytes of program flash, half a kilobyte of EEPROM, and half a kilobyte of RAM. And as you can see in the pin diagram, it has 5 digital I/O pins, 3 analog pins, and 2 PWM capable pins. Now, technically, including the reset pin, it does have a 6th digital I/O pin, but to keep it simple, I'm just going to stick with the simplified diagram here. So let's get started with programming the ATtiny45 or 85. The only materials required to do this is an Arduino, an ATtiny45 or an ATtiny85, a 10 microfarad capacitor, a breadboard, and some jumper wires, preferably new ones. And the reason that I specify new jumper cables is because 90% of the time when I would get errors trying to program this, it was due to a faulty cable. And the same also goes for the breadboard. If it has very loose connections or it's been used with very high currents, that could also potentially cause errors when trying to upload. So the first and most important step is to set up the Arduino as programmer. This will allow the Arduino to be the middleman between the computer and the ATtiny when uploading programs. It's a quick and easy process, and I'm going to switch over to the computer now to show you exactly how to do it. So with the Arduino IDE now open, the first step is to go into File, Examples, and then go right down to number 11, Arduino ISP. It should open a new window with a very large sketch that you do not need to modify, and the next step is to plug in the Arduino into your USB port. With the Arduino now connected, you should now select the board and the port. So in my case, the IDE has not automatically recognized the Arduino. I will do it manually by going into Tools, Board, Arduino AVR boards, and Arduino Uno. Next, if you're on a Windows computer and you don't know what the COM port is, you'll want to go into Device Manager, and then go into the USB Serial Devices tab, if I remember the name correctly, and find the COM port from there. So in my case, when I go into Tools and go into Port, it has already recognized Arduino Uno. And if for whatever reason you cannot find the COM port, switching USB ports usually helps. So with the Arduino port and board now selected, all that's left to do is just hit Upload. And this will upload the Arduino ISP sketch. So once it is done uploading, you can just unplug the Arduino and we'll move on to the next step. So with the Arduino ISP sketch now uploaded, all that's left is to unplug the Arduino board. And now it's time to wire up the ATtiny. So I will pick one of these ATtiny85s here. And this step of wiring is one of the things that actually confused me quite a bit when I was first learning on how to do this. Because for example, a guide might say that connect pin 1 to Arduino pin 10, but they wouldn't specify whether it's digital pin 1, so this one, or the physical pin 1 on the chip, so this one, reset. And sometimes they'd even go back and forth, which made it even more confusing. So in this video, I will always be referring to the physical pin number. So no matter what chip you're using, you can always tell what the pin number is because there's always a tiny little dimple where you count the pins in a U shape. So 1, 2, 3, 4, 5, 6, 7, 8. And this is universal for basically every integrated circuit. And these pin numbers are referring to the actual physical pin numbers that you see on the inside here and not the ones in the bubbles. So placing the ATtiny at the very top of the breadboard, you will require 6 jumper cables in order to connect the ATtiny to the Arduino for programming. So the first connection is of course VCC or 5 volts, which in this case is pin 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that goes to 5 volts, and I'm going to switch my wire color here. So using a red wire for 5 volts, I will plug that directly into the 5 volt pin on the Arduino Uno. The second connection is ground, which is pin 4. 1, 2, 3, 4. And then going to ground on the Arduino as well. The third connection is physical pin 7 on the ATtiny to digital pin 13 on the Arduino. So 1, 2, 3, 4, 5, 6, 7. Next is physical pin 6 on the ATtiny to digital pin 12 on the Arduino. So physical pin 6 is one below physical pin 7. And that is going to go to digital pin 12 on the Arduino. So there's 2 more connections to go. Physical pin 5 on the ATtiny to digital pin 11 on the Arduino. So physical pin 5, that's one below the physical pin 6. And that is going to go to pin 11 on the Arduino Uno. And for the last connection, physical pin 1 on the ATtiny to digital pin 10 on the Arduino. So that is the first pin, physical pin 1, going to digital pin 10 on the Arduino. Now making sure that all of the wires are securely in place. Just pushing down on them. And the final step in terms of hardware is to connect a 10 microfarad capacitor between reset and ground on the Arduino Uno. So reset and ground are usually on the same rail that the analog pins are on, so putting the positive into reset and the negative of the capacitor into ground. So just to make things more compact, I'm just putting it directly into the rail here. So the shorter pin goes into ground and the longer pin goes into reset on the Arduino. So with that 10 microfarad capacitor now inserted, we can now proceed to the IDE. So going back into the Arduino IDE, there's just a couple more steps left before we can start uploading to the ATtiny. And the first one is to install the ATtiny as a board, so that the IDE knows how to communicate with the ATtiny. So to do this, you will want to go into the Preferences tab of the Arduino IDE. So in Windows, I believe that is under File, Preferences, and on Mac, it is Arduino IDE, Settings, and somewhere near the bottom here, you will find something called Additional Board Manager URLs. And this is basically a secondary method of installing boards other than the board manager. So there is a link that I will leave in the description that you will just want to copy and paste directly into the board manager URL, right into the box. And this is basically for the ATtiny board manager, which will give you the required files. So after pasting that, just click OK. After doing that, go into the board manager tab and just type in ATtiny. You should now see the option for ATtiny by David A. Mellis, and the most recent version should be selected by default, and just click Install. It's a very quick installation. You saw that it was very quick to install it. And once that is done, you'll just want to close the Arduino IDE completely and then restart it. This will reload all of the boards and libraries. So now let's check if it worked properly. Let's go into Tools, Board, and there should now be an option for ATtiny. And under that, there should be 2 things, ATtiny25/45/85, or ATtiny24/44/84. In this case, we will be doing 25, 45, 85. But before doing that, we'll want to connect the Arduino back to the computer. So simply taking the programming cable and putting it right back into the Arduino. And again, making sure no wires are loose. And now it's finally time to upload our first program to the ATtiny. So first, you'll want to go back into Tools, and this time you'll want to go into Board, ATtiny, ATtiny25/45/85. Then go back into Tools, go all the way down into Programmer, and then select Arduino as ISP. This will tell the IDE to actually use the Arduino as the middleman between the computer and the ATtiny. Next, you'll want to go back into Tools and make sure that your clock is either on 1 or 8 MHz. For our first test, we'll keep it at 1 MHz. And then finally going into Tools one last time and selecting the port. In this case, it is the Arduino Uno port. So notice how even though the board is selected as ATtiny, it still recognizes Arduino Uno in the port. And the second last step is to select which CPU you're using. So in this case, it is the ATtiny45. So if you are using a brand new ATtiny, it will probably not have a bootloader already burned on it. In which case you will want to go back into Tools and then click on Burn Bootloader. So it says burning bootloader here, done burning bootloader. And if there is an error here that shows up and you know that there is nothing wrong with your chip, it is most likely either the wires themselves, the breadboard, or a combination of the two. Sometimes the little pins on the IC don't reach deep enough on certain breadboards, or the most common issue that I've had is that one of the DuPont headers, I think they're called, the little black ends on the jumper cables, while they may look intact, if they've been used a lot, they may not be providing a proper connection. So with the bootloader now burned, the ATtiny is now ready for use. So just to test it out, I'm just going to upload a blank sketch to the ATtiny. And the way that sketches are uploaded via Arduino as ISP is just one step different than normal sketches with an Arduino. Because if you just try to click the upload button here, it's not going to work. And this is something that I remember it took me forever to figure out back then because there were basically no guides on how to do this. And the video by Make Magazine didn't even mention it back then. But basically when you want to upload to the ATtiny, you'll want to go into Sketch and upload using Programmer. That is the key step. So I'm just going to click that, upload using Programmer. It's going to compile the sketch, uploading, and done. So we know it works, so let's load up the Blink sketch, and I'm going to show how to modify it to work on the ATtiny. So I'm going to go into File, Examples, Basics, and then the Blink sketch. It'll open a new tab, and here is what you'll want to change. Where it says LED built in, I will put an image of the pinout on the screen here, and it is at this point that I will be referring to the digital pin numbers of the ATtiny instead of the physical pin numbers. So the little numbers in the blue bubbles are the digital pin numbers, just like on an Arduino. So in this case, I will go with digital pin 4, so just backspacing all of this and just putting 4 as output, and doing the same for every other instance of LED underscore built in. So the program is now configured to blink an LED on digital pin 4 on the ATtiny, which corresponds to physical pin 3, which is another point that always confused me back when I was learning how to do this. So with it now set up, we can just go back into Sketch and upload using Programmer. We can see it says done uploading, and also notice how it says the maximum is 8,192 bytes. Or 8.2 kilobytes, which is approximately the space that's free in the ATtiny85. So our program is now live on the ATtiny, which means it's time to plug in the LED and see if it worked. So with the program now uploaded to the ATtiny, I'm just going to unplug the Arduino. And in the Blink sketch, we had set digital pin 4 as the output, which in this case is physical pin 3. So in order to connect the LED, I will take a 220 ohm resistor and connect it to pin 1, 2, 3, physical pin 3. And then putting that to a new rail. So physical pin 3, 1, 2, 3, is now connected to a free rail. Then I'm going to take this green LED and put it with the positive to the resistor and the negative to another free rail. And then finally connecting the ground pin of the LED either to ground on the Arduino or, to keep it more simple, the ground pin on the ATtiny. So in this case, ground was physical pin 4. So 1, 2, 3, 4. Now at this point, all of these extra programming wires may be removed from the ATtiny, of course except for the 5 volt and ground, and it can then be powered with anything up to 5.5 volts. But because I plan on adding a second LED to the sketch, I'm just going to keep them on. And now for the moment of truth, let's connect the power back to the Arduino and see if it starts blinking. And look at that. This is all from the ATtiny, not from the Arduino. And I'm going to prove it at the end of the video by taking out all of these wires and powering it from a lithium battery. So now that it works, let's unplug it and go and modify the sketch to add 1 or 2 more LEDs. So this time I'm going to plug in the LED before actually coding it. And to clean it up a bit, I'm going to put the negative onto the negative rail here, just so that the LED can just directly go into the negative for the negative pin. And this time we're going to use digital pin 3 on the ATtiny, which corresponds to physical pin 2. So physical pin 2 is this one, 1, 2. So connecting that resistor to physical pin 2 to another free rail. Again, making sure all of the wires are intact. And then connecting the second LED from the resistor to ground. Just like that. So now let's go back into the IDE and set digital pin 3 as an output, and then add the high and low commands to turn it on and off. And now let's add digital pin 3 as an output. So I'm just going to copy this, paste it, and then change the 4 to a 3. And I want the 2 LEDs to alternate, so I'm going to copy this, paste it right beneath it, change the 4 to a 3, but this time set it to low. And then do the same with the other one, except setting it to high. And just to give it a little bit of customization, I'm going to change this to 750 milliseconds. 750. Okay. So now when the first LED is on, the second one is going to be off, and vice versa. So now let's go back into the sketch, upload using programmer. And upload is now complete. So now we can see the 2 LEDs are now alternating. And unfortunately, I put a green one in here, so let me just swap that out with the blue LED. They're both clear, so they look the same. So blue and green. And now finally, to prove that it's actually running on the ATtiny and not the Arduino, I'm going to unplug all of these wires. So I'm going to unplug the Arduino and then take out all of these wires. So everything is gone. It's nothing but the ATtiny and the 2 LEDs and this wire connecting the ground rail. So the ATtiny can take external power from 1.8 volts all the way up to 5.5 volts. So I will be using this tiny little lithium-ion battery along with a battery holder that I designed and 3D printed myself. So it's going to be running on about 4 volts. So I'm going to connect the ground of my battery holder to the ground rail here. And I'm doing this because the ground rail is also connected to the physical pin 4. And then finally, I will connect the positive of my battery holder to physical pin 8, which is VCC or 5 volt. But it doesn't strictly need to be 5 volts, it can be 1.8 to 5.5 volts. So let's put in the lithium-ion battery, and it starts lighting up. So I'm going to take the battery out because I have kind of a cool idea. Let's power this ATtiny with a lithium hybrid supercapacitor, because that is what this channel is all about. So I'm just going to connect the positive pin, physical pin 8, to the positive rail on the breadboard, and ground is already connected to the ground rail. And then I'm going to very carefully insert this lithium hybrid supercapacitor between ground and 5 volts. And look at that. Possibly the world's first lithium supercapacitor powered ATtiny. So this is going to be the end of the video, and thank you for watching my tutorial on how to program an ATtiny45 or 85 using an Arduino Uno. I hope some of the specific details I provided will help solve any issues others are having with programming the chip. Please remember to like and/or subscribe, and I will see you in the next one.